Now, if we have a parallel circuit, what to do? What should be the approach? So don't go for a parallel circuit. So directly get into the problem like this. So let the current here be I1. Let the current here be I2. Shall we calculate first I1, I2? Find the current through the cell is asking. So first we'll calculate current I1. To calculate current I1, I'll replace this with equivalent circuit. There's the impedance Z1. I think the circuit has become really very simple with the approach. What is Z1? Root of R1 square plus XL square. 6 square plus 8 square. This should be 10 ohm. What about Z2? Z2 square, R2 square plus XC square. 4 square plus 3 square. This will be 5 ohm. Then what is the current? I1 magnitude I'm calculating. This IRMS. What I'm writing I1 is IRMS. I1 equal to VRMS by Z1. What is VRMS? 20 by 10. 2 ampere. What about I2? VRMS by Z2. 20 by 5. 4 ampere. So shall I write I1 plus I2? Shall we write I1 plus I2? Tell me like what is this Z1? Is it a lead or lag? There's a lag, no? And what about this lead? So here, what about I1, I2? Will they have any phase? Let me take VRMS as reference. So directly go for phasor diagram. Don't waste much any time. Treat them like a vectors, I1, I2 vectors. Let me take the phase angle of VRMS as 0 phase. Parallel circuit, they're the best up because of course, sir, I know complex number, I'll apply it. Yes, you can do that. Since our syllabus, they didn't decide to use complex numbers, I'm trying to avoid. You can, since you know complex numbers, you can solve with that also. Directly you get I. I'm using simplified approach here. The vector diagram, this is a vector diagram. Now the VRMS is what? The reference I'm taking. 0 phase. This is pi by 2. This is minus pi. Now let's come for this. What is the R1 XL, the Z1? It's a lag, no? What do you mean by lag? What actually lags? Current lags the applied voltage, no? So therefore the I1 should be shown here. What about I2? What about Z2? Is a lead circuit. The current leads the applied voltage. This is the applied voltage. So therefore we have to show that one here. This angle we don't know. This has to be determined. How to calculate the phase angle? Separately, you go back for inductor circuit, RL circuit. So how do we show phase angle? It is like this, no? Little bit orientation will be different. It is justified because I took VRMS as reference. Then similarly, is it okay? No, sir, but till now the problems, the voltage, the impedance triangle for RL should be on the first quadrant, but here you brought it in the fourth quadrant. Shall I bring it also in the second, third quadrant? No, try to look at here. What is the reference? This is the reference. I took the source as reference, the phase of this as 0. Compared to applied voltage, the current in RL circuit lags. Agreed? Compared to applied voltage, this is 0 phase. I took this as reference. So here, but it didn't say to make problem simple, I assumed it. I assumed this to be 0 phase. No, sir, I'll assume this to be 90 degree. As compared to 90 degree, it will lag. So then you have to show VRMS here, then it will come here. I think the overall vector diagram will be like this only. The method will be this much only. So, sir, I'll assume this to be phase of 90 degree. Then you have to show VRMS here. Then where I1 will come, I1 will come here. Then I2 will come here. One of the same. No? This is much easier approach. Take this to be 0 phase. In parallel circuits, always to assume the phase of a source, let it be 0. If we mention this phase separately, then corresponding to that, you draw the diagram. Since nothing mentioned, so if they don't mention anything, then the phase of the cell should be 0 for parallel circuits, I'm telling. Okay, there's a thing. So now can we calculate the phase angle? This phi 2, phi 1 is needed. So what is phi 2? Cos phi 1 equal to R1 by Z1. Cos phi 2 equal to R2 by Z2. I know all the values. Z1, Z2 values, everything. I got cos 1. Now what is the resultant current? The total current through the cell should be I1 square plus I2 square, 2I1, I2, angle between them. Vector addition.
Root of such.
This is I square, or we'll make it here. So whenever you get a parallel circuit, what you should do to get a current in this cell, current in branches will be different. Vector sum of currents is what? The total current is. So you should not write I equal to I1 plus I2, parallel branches. In series branches, vector sum of voltages. Here you can see the drop across V1, R1 and XL. You cannot write V1 plus VL, V1 square plus VL square. When parallel branches come, vector sum of currents. It's a very difficult for you to digest what like current, like a vector addition. But this chapter is of that one. Parallel when you come, so take help of the vector sum of currents. If they are series, vector sum of voltages. Can we calculate how much of phase angle of circuit? If somebody asks what you should do, you should calculate the angle made by the current, you know. So you can do the resultant current along x, or use the vector somewhere. I'm making a guess. I don't know. It will be the resultant current may be here. This is the phase angle of circuit here. So what is I? This I is this one. How much of angle it will make with applied voltage VRMS, that you should calculate by vector diagram, or else you can go for unit vectors like along x-axis how much it is, I1 cos phi. So I can give this tan phi by another method. I1 cos phi 1, I1 you see this tan phi. I can also bring this. This is a phase angle of circuit. If you know phase angle tan phi, you can bring cos phi. Power factor of circuit also you can bring it. I just took the along x-axis, I'll add the components. Along y-axis, I should take the difference. So there should be the tan phi. Or else use the vector algebra formula. Addition of two vectors, the angle made with the resultant with any one. That'll be a little bit more lengthier. This will be easier because you know I to all this one. You'll get the tan phi. So now what is the